All right, this is week 31 and 32 notes. This will take you more than one class period. Go ahead and copy down the definitions first. So what we're doing this week is transformations, which is you have an image on the coordinate plane, and there are 4 different things that you can do to it. We have a pre-image, which is the original image or figure that you start with, and then we have what's called the image, which is the new transformed image or figure. So the 4 things that you can do, the first one is a translation. That's where you slide a figure in the same direction, the same distance. So maybe up 3 and to the right 4. And all the points on your figure are going to go up 3 and to the right 4. We also have a rotation, which is a transformation that turns or spins a figure around a point. We also have a reflection, which is a transformation that flips the figure over a line to create the image. And the last one is a dilation, which is a transformation where you grow or shrink your figure. So go ahead and pause the video and copy down these definitions. Okay, here we go. We're going to start with translations. So we're going to name the type of transformation, and we're going to talk about how the new figure relates to the original figure. So in our first example, we have triangle ABC. Which is the blue one. And then we have the new figure, which is triangle ABC, the black and white one. So the first one is a translation. And what we've done is we've taken triangle ABC, the blue one, that's our pre-image, and we've translated it or moved it to create triangle A prime, B prime, C prime, which is our new figure or our image. And if we look at point A, we can see that point A moved to the left 6 spaces, and then it continued its journey and it moved up 5 spaces. When we move left or right, that's our x-axis, and that was 6. And when we move up or down, that's our y-axis, and that was 5. Remember which ones are negative? When we move to the left, it's a negative, and when we move down, it's a negative. And that same rule, left 6, up 5, holds true for all 3 points. So we looked at A first, and now we're looking at point B. And then finally point C also moved left 6 and up 5. And we're going to put a little apostrophe after the letters on our black and white triangle. That shows us that that's the image, not the original. Next, we're going to look at the second one, and you can see our original is the blue triangle ABC, and our image, our new figure, is A prime, B prime, C prime. And we can tell because they have apostrophes after the letters. On the third one, I'm going to add the apostrophes as well, so you can tell that the black and white triangle is our image, our newly created figure. And on the very last one, we'll add the apostrophes as well, so we can tell which one is our original pre-image and which is our image. So now let's continue on. We're looking at the second one. What type of transformation is that? That is a rotation. Our blue triangle was rotated 90 degrees clockwise. Same rotational direction as the hands on the clock. The next one is a reflection. This one is a reflection over the y-axis. We can look at our points and see the last one is also a reflection. This one is reflected over the x-axis. Okay, we're going to complete the statement using the description of the translation. In the description, points 2, 0, and 3, 4 are two vertices of a triangle, so 2 points on a triangle. So A, if 2, 0 translates to 4, 1, then what would 3, 4 translate to? So what we're going to do is we're going to look at our x in our x, y's. So we're going to look at the 2 and the 4. Those are the x's in those first two ordered pairs. We're going to see how they relate to each other. So if you're translating and you go from 2 to 4, what did you do? Since it's our x, we're going to put x, and then 2 to 4 is adding 2. So that rule is x plus 2. Now let's look at the y's, which is 0 and 1. So it's going to be y plus 1. To get from 0 to 1, we add 1. So now we're going to use that rule and we're going to apply it to our 3, 4 ordered pair. So to our x, we're going to add 2. So 3 plus 2 is 5. And to our y, we're going to add 1. 4 plus 1 is 5. So 3, 4 would translate to 5, 5 using that rule. Okay, let's look at B. If 2, 0 translates to -2, -1, then 3, 4 would translate to blank. So again, let's look at our x terms. We have 2 and -2. Well, that one is going to be subtracting by 4. And then we look at our y's. We have 0 and -1. To get from 0 to -1, we're going to subtract again, this time only 1. So that's our rule that we're going to apply to our 3, 4. So 3 minus 4, -1. And 4 minus 1 is 3. So 3, 4 in this case would translate to -1, 3. For the next example, a point on an image and the transformation are given. Find the corresponding point on the original figure. So the point on the image is 2, -4. And we have our rule. The original x, y transformed to x minus 4, y plus 3. So remember, the point on our image, 2, -4, is the end, right? Our result. And we have our rule, -4 plus 3. So they want to know, where did we start? So if we have our x term and we end at 2, and we subtracted 4, what number minus 4 is going to give us 2? The point on the image, 2, -4, is our result. Our rule is x minus 4. So what number, when you subtract 4, is going to give you 2? That number is 6. 6 minus 4 gives us 2. So now let's look at our y. Our rule for y was adding 3. So we added 3, and our result was negative 4. So what number plus 3 is going to give us a negative 4? Well, that's negative 7. And that's our ordered pair that we began at. So let's do the second one. A point on the image, so our end result is negative 5, negative 7. If you look at our transformation rule, x comma y transformed to x comma negative y. So x stayed the same. So if x is negative 5 and it stayed the same, well, it was negative 5 to begin with. And then y became its opposite. It says negative y, which you think of as opposite y. So if it resulted at negative 7, well, what's the opposite of negative 7? Positive 7. And that was the original point that we started at, to end at a result of negative 5, negative 7. Turn the page when you're done. You're going to need to draw these on your paper. Pause the video to make sure that all the images are drawn on your paper before you continue on. Also with these, pause the video to make sure all of the points and figures are drawn on your paper before you continue on. Okay, we're going to begin. Figure ABC has vertices A, negative 3, 3, B, 1, negative 1, and C, 0, 5. We're going to sketch ABC, and already done hopefully, and we're going to draw the image after the translation, x plus 4, y plus 2. So we're going to start with just one point, and we're going to transform the x term, positive 4. So when we move on the x-axis, that's either to the left or to the right. Point A is negative 3, 3. So if we add 4 to our x term, we end up at 1. And then we're going to add 2 to our y term, and we're going to end at 5. So A prime is going to be 1, 5. You can always do these algebraically by simply adding the rule to your ordered pairs. You can also do them just on the coordinate plane. So moving left or right for x, and moving up or down for y. Remember, left is negative for your x, right is positive. So it's going to be to the right 4 since it's positive 4. And then on our y-axis, we're either going to move up or down. Since it's positive 2, we're going to go up 2. So each point ABC is going to be moved to the right 4 spaces and then up 2 spaces to create our image. A prime. We moved to the right 4 and up 2. B prime. We moved to the right 4, up 2. And C prime, we're going to move to the right 4 spaces and up 2. Now we have the vertices of our image, so we're going to connect those to create our image. And let's verify our algebra over here on the right. We said that A prime was supposed to be at 1, 5. So let's double check A prime. 1, 5 looks good. We're going to shade in our image and make sure that there's apostrophes after the A, B, and C. So everyone can tell what the original pre-image is and what the image is. Okay, moving on to number 2. we're going to translate this one. X comma y is going to become x minus 6, y minus 3. So these are both negatives. So instead of moving up and to the right, we're going to be moving to the left and down because they're negative. So x is going to be negative 6, so that means we move to the left 6 spaces. And y is minus 3, so that means we move down 3 spaces. So remember, you can always write your ordered pairs and then subtract 6 from your first number, the x term, and subtract 3 from your second number, the y term. Or you can just move the points. We're going to start with A, and we're going to go to the left 6 and down 3. The thing to note on here is that each graph square is worth 2, which is probably why you're wondering why doesn't it look correct. So we actually are moving 2 numbers per graph square. Remember, you can always pause the video if you need extra time to finish. Number 3, our translation is x comma y becomes x plus 5, y plus 1. So since it's positive on our x, we move to the right 5 spaces, and y plus 1 means we're going to go up 1 space. These graph squares are only worth 1, so we can simply count to the right 5, up 1 for each point. Start with A, move to the right 5 spaces, and then up 1, and then plot your new A, which we call A prime, with the apostrophe. We're going to have you guys do that one on your own and move on to number 4. We're just looking at the rule here. We know that point A moved to the right 5 spaces and then down 1 to become A prime. So if you move to the right on the x-axis, that means plus 5. And then we moved down 1 space. So on our y-axis, down means negative and 1. So we're going to write our rule. So x, y became x plus 5, y minus 1. So if you have 2 figures, you can easily write the rule by figuring out how many spaces they moved to the right or left, and then how many spaces they moved up or down. Okay, make sure you finish number 3. Example 5, when translating a figure, how does the image compare to the pre-image? So what do you notice about your original figure and the new figure that we've created? Are they the same? Are they different? Well, the actual shape is exactly the same. The only thing we've done is moved it. So in geometry, when we say 2 things are the same, we call them congruent. So we're going to write that these 2 images are congruent, which means that they have the same shape and also the same size. When you translate a figure on the coordinate plane, the pre-image and the image are always congruent. The only thing different is the position on the coordinate plane, so a different spot. The very bottom, you're going to draw an example of a pre-image and an image, keeping in mind that they need to be congruent. You can put a coordinate plane down if you'd like. Just make sure you draw an image of some sort and then translate it to another spot on the coordinate plane and draw a congruent image. Go ahead and turn the page when you're done. The next thing we're going to talk about are reflections. You guys know what a reflection is. You're familiar with the term. It's a mirror image. Reflections are mirror images of each other. You have an original figure that is flipped over a line. It's usually the x or the y axis, but not always. Another way to think about reflections is each point on the figure, each vertice, is exactly the same distance from your line, from the line of reflection, which is also sometimes called the line of symmetry. Those two terms are interchangeable. They mean the same thing. These three examples, our line of symmetry is all the y-axis. And what we're asked to do is to draw the other half. So for the first one, our y-axis is our line of symmetry or line of reflection. So it's going to be mirror image on the right-hand side. So we just need to continue drawing that figure. Make it look exactly like it does on the left to create that mirror image. Okay, so we have a bubble letter T. The second one, again, the y-axis is our line of symmetry or line of reflection. So we're going to make it look exactly the same on the right as it does on the left. Can you tell what we'll create when we do that? It's a letter A, capital A. And again, our y-axis is our line of symmetry. So for the third one, we're going to use the fact that it's the same distance from each point to the line. So here's our line. So we're just going to start with each point and see how far away it is from that line. Okay, so that's one space away. So we're going to create our mirror image that's also one space away, but on the right-hand side. Up here, this one's 2 spaces away. So we're going to create our image, which is also going to be 2 spaces away from that y-axis. This one also is 2 spaces away. So we're going to move 2 spaces to the right from the line. This one is 3 spaces to the left of the line, so we're going to make a point that is also 3 spaces, but to the right of the line. And the last one, 3 spaces to the left, so 3 spaces to the right. And those are your vertices, which you can connect to create your image. Okay, the next one we're going to talk about are the rotations. A rotation is a transformation that turns or spins a figure around a point. Point of rotation, it's sometimes called. So if we look at our first example, we have the letter F, and we see that it is spinning to the right, so clockwise, the same direction. And we can tell how many degrees. So it says it was rotated 90 degrees, but that is not correct. So I want you to cross off 90 degrees, and we're going to figure out how many degrees it was rotated. So I'm going to start with a point on the top of my F, and I'm going to create a line that goes straight down to the origin, my point of rotation. And I'm going to do the same thing on my image. Start with a point on top of the F and create a line that goes straight to my point of rotation, which is the origin. And then we're going to look at what those two lines create together. And we can see we have an angle. We're going to measure that angle. And this one is actually 140 degrees. So the letter F was rotated clockwise 140 degrees about the origin, or you can say around the origin. Those two words are interchangeable, they mean the same thing. The next one shows you what a triangle would look like if it was rotated about a point on the figure itself. And the last one shows you what that triangle would look like if you rotated it around a point that's not on the triangle. Here's another way to think about rotations. You have your image and your pre-image. We can tell which is which because the pre-image has our apostrophes. So that one is our image, and the green one is our the green one is our image, and the red one is our pre-image, what we started with. And we can take point A and point A prime and draw the lines. So we're going to start with point A, draw a line to the point of rotation, the origin, and then take A prime, do the same thing, and we're going to look at that angle that's created. This one we're looking at the outside angle, so we can think of this as rotating to the left or counterclockwise, 270 degrees. Which you can also tell is the exact same thing as rotating it to the right, 90 degrees. You see the 90-degree angle there? But they were looking at how many degrees it rotated counterclockwise. So you could say it rotated counterclockwise 270 or clockwise 90. So we're going to rotate this figure now. Here's the steps. We're going to rotate it 90 degrees clockwise. So we're going to start with each point, and we're going to draw a line, a straight line, to the point of rotation, which is just going to be the origin. So we're going to start with point A. We're going to draw a line from point A to the origin. And then we're going to make a 90-degree angle. It's got to be the same length of a line. And it's got to be a 90-degree angle. Let's make it red. Okay, so we have a 90-degree angle there, and our two lines are the same length. So that's going to be point A prime. We're going to do the same thing with B. We're going to draw a line from point B to the origin. And we're going to create a 90-degree angle. And we're going to make that line the same length. And we can see where B prime is going to go. Okay, next we're going to do point C. We're going to draw a straight line from point C to the origin. We're going to do a 90-degree angle with that green line and make it the same distance, same length. .90-degree angle, same length. That's going to be C prime. And last we're going to do D. D doesn't have a letter for some reason, but we know it's the last one. So we're going to draw a line from that last point down to the origin, create a 90-degree angle, and make our line the same length. Create point D prime. And now we can connect those 4 points to create our image. This is just one way to do a rotation. There are other ways that we can show you if you'd like when you're working on your rotation packet. Okay, turn the page. We're going to move on to dilations. Dilations is the only transformation that changes the shape. It actually changes the size. When you multiply the coordinates by a scale factor, which we call k, you're going to change the shape or the shape's size. If your scale factor is less than 1, your image will shrink because you're multiplying it by something smaller than 1. If your scale factor is greater than 1, your image will grow. And then if you simply multiply it by 1, it would stay exactly the same. So the definition of scale factor is a number that scales or multiplies your figure. A number that scales or multiplies your figure. Your figure will either grow or shrink. Your image is either larger or smaller than the pre-image. Remember, the pre-image is what you start with. The image is your end result. So how to determine the scale factor? You're going to write the ratio. Remember, ratio is just a fraction. You're going to write the ratio or fraction of two corresponding parts or sides. Corresponding means they're in the same position, but on a different shape. So if you have a rectangle, the corresponding sides would be both the sides on the right-hand side. Or the top would correspond to the top on the other one. Corresponding just means that they're matching, they're in the same position, but on the different shapes. So example 6, state whether each dilation using the scale factor k would result in a reduction, smaller, or an enlargement. So A, k equals 3. Is that more than 1? And what happens when we use a scale factor that's larger than 1? What happens to our pre-image? Our pre-image becomes larger. So that one would be an enlargement. And what we would do is we would multiply each coordinate by 3. So if your ordered pair was 1, 1, multiply them by 3, and it would become 3, 3. The second one, our scale factor is 1/3. Well, that is less than 1, so that would be a reduction. Your image would shrink. And you could take each coordinate and multiply it by 0.3, repeating. The next one, k equals 5/4. Well, it's a fraction, but it's an improper fraction. We could turn it into a mixed number. 4 goes into 5 once with 1 left over, and the 4 stays the same. So that's actually more than 1. It's 1 1/4. So that would be an enlargement. And we would take our coordinates and multiply them by 1.25. 1/4 is 0.25. And the last one, k equals 0.93. Is that less than 1? Yes, 93 cents is less than $1. So that would be a reduction, but just barely. It's only going to be slightly smaller. And that one's already a decimal, so you would take your coordinates and multiply them by 0.93. Example 7. Determine whether the dilation from figure A to B is a reduction or enlargement. So we're going from A to B, and then we're going to find the scale factor. So I drew arrows. Example A, we can see that if we go from A to B, our triangle is getting larger. So that's an enlargement. And we're going to find the scale factor. Remember, we're going to write a ratio. So a fraction. And the rule for our ratio, which you might want to highlight, this is important, is the numerator is where you end, and the denominator is where you start. So let's look at our corresponding sides. Okay, we cannot use those two because they both don't have a number. One of them is a variable. So let's look at more corresponding sides. The 7 and the 14 correspond, and those both have a number. So we're going to write a ratio using those two numbers. End over start. So which one did we end at? Which one did we start at? Well, we ended at 14, and we started at 7. And we can tell because of the arrow. We went from A to B. So our scale factor is 14 over 7, which we must simplify. Our scale factor is 2. And you could easily figure out the rest of the letters. If we look at our first corresponding side, it was 8 and M. Well, our scale factor is 2, so we multiply 8 by 2. So M would actually be 16. N would be 20. Let's look at the next one. We're going from A to B, so we're starting at the large one, and we're ending at B, our smaller one. So that is a reduction. Again, we're going to come up with our corresponding sides, and we're going to use our ratio end over start. So if we look at the top, we have 6 and Y. Those both don't have numbers, so we can't use those corresponding sides. If we look at the left side of our rectangles, we have an X and a 3. That's not going to help us either. Let's look at the bottom of our rectangles. We have a 6 and a 2. That will work because they're both numbers. So we end and start. Where do we end at? Where do we start at? We ended at 2, so that's our numerator, and we started at 6, so that's our denominator. We must simplify this. 2 over 6 simplifies to 1 over 3. So k, our scale factor, is 1/3. Okay, if we look at point C, example C, we have figure A and figure B, and we know that we start at figure A and we end at figure B. So if we start at figure A and we end at figure B, is that a reduction or an enlargement? Well, it's getting bigger, so that's going to be an enlargement. So make sure when you find your scale factor, since it's an enlargement, we know it has to be more than 1. And we're just going to take a look at some of these coordinates. I see that this piece right here is 1.5. That's where we start at. So that's going to be our denominator. And then the corresponding part, we'll draw in blue, and that one is 2. So our scale factor is 2 over 1.5. Well, let's turn that into a decimal. So we're going to divide. 2 divided by 1.5. Calculator would be easiest to figure this out. You end up with 1.3 repeating. I like to have my scale factors in decimal form because when I need to multiply the coordinates, I like to multiply using decimals rather than fractions. So our scale factor is 1.3 repeating. And remember, we got that by doing 2, our numerator, divided by 1.5, our denominator. And it's supposed to be an enlargement that is greater than 1. So that checks out. Okay, I want you to go ahead and draw this figure with me. Triangle ABC has coordinates as follows. A, 1, 2. B, 2, 3. And C, 2, 1. That's our pre-image. That's what we're going to start with. Let's create our triangle. And now we're going to dilate it using a scale factor of 2. So we're going to take our coordinates and multiply them both by 2. So if I take 1 and multiply it by 2, and then 2 and multiply by 2, that will give me my A prime. So 1 times 2 is 2, and 2 times 2 is 4. So A prime, the coordinates of that would be 2, 4. So go ahead and plot that and label it A prime. Don't forget the apostrophe. For point B, 2, 3, if we multiply both of those numbers by 2, 2 times 2 is 4, 3 times 2 is 6. So our new vertice for B prime is going to be 4, 6. Go over 4, up 6. Label it B prime. And our last one, C, is 2, 1. Multiply both of those by our scale factor of 2. 2 times 2 is 4, and 1 times 2 is 2. Plot C prime, go over 4, up 2. And we're going to connect those 3 points to form our image. We dilated it by a scale factor of 2, so which is more than 1, so it should be an enlargement. I'm going to shade it in. Note that that's our image. And that's our pre-image, what we started with. You don't have to label those, I just wanted to show you. Okay, keep these notes. You're going to use them throughout this week and next week as you complete your packets. Make sure you check off as you complete them.